Spirent's Cloud and IP Business Unit Spirent TestCenter platforms are test and measurement tools for verifying the network and cloud evolution. Spirent has been a leader for network testing for over 20 years. That experience is embedded into our industry-leading hardware and software platforms, which have been proven over multiple generations of network technologies. Whether you are using the highest density chassis-based platform, the more mobile appliances, or our software-based virtual systems, all Spirent TestCenter platforms can interoperate and cooperate in a single test, allowing you to tailor the test infrastructure to deliver optimal results without breaking your budget. Service providers, network equipment manufacturers, NEMs, and enterprises wishing to keep pace with the latest technologies use Spirent TestCenter as their end-to-end testing solution, from traditional performance testing to detailed tests of virtualization, cloud, mobile backhaul, and high-speed Ethernet. This slide mentions some of the key initiatives currently underway at Cloud and IP, or SIP. Spirent TestCenter supports testing of both the legacy and evolving technologies. From simple packet generation analysis to network protocol emulation, Spirent TestCenter delivers high capacity and repeatable performance to benchmark and tune your infrastructure for optimal, secure, and predictable performance. SIP is the largest business unit within Spirent and is headquartered, including final manufacturer assembly, in Calabasas, California. Although, as the slide depicts, there are major R&D facilities located worldwide. Spirent SIP is a trusted advisor to over 2,000 customers in over 80 countries for over 25 years. I've actually been with the company over 20 years myself. SIP's flagship product, Spirent TestCenter, is the market share leader for high-speed Ethernet testing solutions. And we have appreciated even greater growth with new 5G, Wi-Fi, cloud, automotive, and timing solutions. SIP delivers complete end-to-end solutions for verifying and assuring network and cloud infrastructure and deployments. This enables our customers to test, measure, and validate their networks and deploy new services and applications with confidence, as well as to continuously innovate new technology for testing tomorrow's networks. Promise assured. Spirent TestCenter is sold three different ways. 1, as modular chassis. 2, as fixed appliances. And 3, as virtual machines. Note that these all have similar capabilities but do vary in functionality and scale. Appliances, especially the C1, could be considered as entry-level, especially for enterprises who don't need service provider or network equipment manufacturer scale. In many cases, appliances are purpose-built for certain markets. For example, an automotive C50 appliance with broad R-reach interfaces, or a Wi-Fi C50 appliance supporting Wi-Fi 6 interfaces. We also recently released a new C2 appliance for Wi-Fi and enterprise markets too. There are also our chassis-based solutions, which are more flexible for higher performance or port density options. And finally, test port functionality has also been virtualized for testing in the cloud, or at least deployed on a hypervisor or even commercial off-the-shelf or COT hardware. Notice that either the GUI application, even web-based TestCenter IQ, as well as application programming interfaces, or APIs, are compatible across all these platforms. In fact, different types of platforms can even be mixed and matched in a test, all timed to a single source, be it internal, NTP, PTP, or GPS. This is a pretty busy slide, but at least it is a record of the protocols that SIP's Spirent TestCenter supports. We have everything from stateless traffic generation analysis, stateful application layer protocol traffic, and layer 2, 3 protocols for routing, switching, data center, access layer, or core, even 5G protocols. Typically, licenses for these are sold either individually or in test packages, grouping similar functions. For the most part, I like to say that if it is standard, then SIP supports it. Start with that mindset, but then let your Spirent account team help to sort out the details of your specific requirements. To a certain extent, all platforms support all functions, but some may be limited in scale, at least as a trade-off for higher port density and lower cost per port. Spirent's TestCenter has a Windows-based GUI control application, web-based results analysis with TestCenter IQ, as well as common and RESTful APIs. Spirent TestCenter also supports our methodology-driven web applications accessed using our Tamiva portal. The control application and APIs allows the user to configure the test topology, traffic generation using streams and flows, protocol emulation using Spirent TestCenter devices, as well as test execution and coordination allowing the starting and stopping of traffic, emulation, and capture, with results and analysis reporting based on both port-based and stream-based counts, events, and rates. In addition, the Windows-based GUI control application provides wizards to assist with configuring and executing a wide variety of standards-based and technology tests. For example, built-in RFC 2544 and 2889 traffic tests and routing and MPLS test emulation wizards. As mentioned on the previous slide, Spirent TestCenter includes a Windows-based GUI control application which provides wizards to assist with configuring and executing a wide variety of standards-based and technology tests. The Windows application depicted here includes a test setup on top, the classic results on the bottom, as well as wizards to set up and execute tests, and automated GUI execution using the command sequencer, but not depicted here. Besides the embedded classic results, there is now a web-based results application, TestCenter IQ, which is discussed next. As mentioned on the previous slide, TestCenter IQ is a new web-based results and analysis application released in 2019. The TestCenter IQ platform enables accelerated troubleshooting, reporting, and testing cycles through a powerful set of customizable searching, charting, reporting, and event monitoring tools, all controlled through an easy-to-navigate web graphical user interface. Just FYI that TestCenter IQ is included with the Spirent TestCenter application at no additional charge. Just like the telecommunications industry is evolving, so are SIP applications and our drive to open source and web-based ease of use. TestCenter IQ is a recent example of that. Next, you'll see another example with Enhanced Layer 4 through 7 solution, which now provides our stateful traffic emulation. Previously, we mentioned Spirent TestCenter's stateful application layer protocol traffic support. This slide identifies these capabilities even further with our Enhanced Layer 4 through 7 solution, which is a new web-based application also released in 2019. This provides the capability to generate stateful Layer 4 through 7 traffic over emulated topologies with Spirent TestCenter IQ-based results correlation, as well as the ability to have concurrent Layers 2 through 3 and Layers 4 through 7 traffic on the Spirent TestCenter platforms. As mentioned previously, Spirent TestCenter Windows application has built-in automation for test execution using the command sequencer. But Spirent TestCenter also supports automation via scripts using the APIs. Because of this, Spirent TestCenter tests can be incorporated into our customers' automated development, regression, and manufacturing environments. Spirent TestCenter has many hardware module tiers to address different use cases and market positioning. I will start by noting that regardless of the tier, all tiers offer line rate transmission and analysis of data plane packets as well as capture capabilities. First, the DX tier offers the highest port density but at a lower cost per port, and with more limited control plane and data plane scale. Typical use cases for the DX tier are high-density switch fabric testing and high-density system-level tests. Second, the PX tier also offers the highest port density, still at a lower cost per port, but not as low as the DX tier, but also along with higher control plane and associated data plane scale. Typical use cases for the PX tier are high-density fabric and protocol testing, as well as high-density and protocol scale system-level tests. So I emphasize now that the main difference between the DX and the PX tiers is that the PX tier offers higher scale protocol testing. Third, the FX tier increases the scale of protocol testing and also data plane scale test as well, but at a little bit higher cost per port than the DX and PX tiers. It also offers the highest precision in stream rates, gap control, and timed transmission, and hardware capture capability at line rate. Typical use cases include high-scale functional and protocol testing, conformance, and performance or data plane testing. Finally, the MX tier offers the highest functional and performance testing capabilities, but at the highest cost per port. As such, it offers the highest control plane scale and performance, the highest data plane scale, the highest precision in stream rates, gap control, and time transmission, as well as the highest level of data frame instrumentation and configuration. Typical use cases include functional, conformance, and performance testing, high-scale protocol validation and performance testing, and multi-protocol performance testing. Let's assume that you just received a new Spirent TestCenter. Your shipment included a literature pack with a license entitlement ID certificate. The license for your equipment is not installed at the factory, so you can go to our support site, https://support.spirent.com, and access the license activation to fulfill and download your license file. Then use that with the Spirent TestCenter application to upload to the chassis appliance virtual license server. In addition to the literature pack, a cable pack is also included with your new hardware. You can use either the blue or white cable to connect the chassis or appliances management port to your management network. Otherwise, there is a purple cable used to time sync one chassis to another, or even a timing chain for many chassis and/or C2 and C50 appliances simultaneously. If you own an N4U or N12U chassis, previously N11U, you can browse to it and download the Spirent TestCenter application. That ensures that all your users install the same version of the application, which will match the chassis' installed firmware, which is a requirement. Otherwise, the application, firmware, and documentation can be downloaded from our support site. Note that 5.13 as depicted here was released in September 2020. Spirent TestCenter supports three main functions. First, there is PGA or Packet Generation Analysis, which is simulated traffic configured using stream blocks in the application. Second, there is emulation protocol support, for example, network emulation like BGP, OSPF, and host emulation like PPP, DHCP, configured using devices in the application. And third, there is stateful application emulation configured using the enhanced layer 4 through 7 in the application. All three of these work together in the Spirent TestCenter application, where even a single device can perform all simultaneously. Also note there is the capability for conformance testing, but that is implemented using a separate application. Note that systems support all functions, but some are limited, so let your Spirent account team help to sort out the details of each customer's requirements. The remainder of this presentation and demonstration will focus on Packet Generation Analysis, or PGA. It will show how to quickly set up to generate and analyze test traffic between two Spirent TestCenter test ports. Now let's dive a little deeper into PGA. All systems come with a PGA license. PGA is for simulated traffic, or stream blocks, consisting of layers 2, 3, and layer 4 plus headers. Either raw layer 2 traffic with no IP, or also including stateless UDP and TCP headers. For TCP specifically, that just means to generate traffic with valid and configurable TCP headers, but without state being established, and no sequencing and acknowledgements. For IP layer emulation, PGA supports ARP and ND to resolve a neighbor's MAC address, and ping. But whereas you can use PGA to generate multicast traffic, you'll require an IGMP MLD license to initiate client device joins and leaves. For IP layer simulation, you can configure raw stream blocks to represent a certain traffic type either not supported by emulation or maybe something that is non-standard. PGA is used for traffic performance testing either for unicast, QoS, or multicast, although as mentioned, multicast client emulation requires a separate license. Finally, capture and error generation are also included with the PGA license. Inevitably, you'll be working and eventually have a question. This slide lists some of the self-service options that can help get your questions answered quickly. When you are working in the Spirent TestCenter application, you can press your F1 function key to access context-sensitive help, meaning it should open to the screen that you are on. The Spirent Customer Service Center, or CSC, has a knowledge base, a KB, that you can browse or search. Make sure you log in first, and specifically the KB has a training channel, which is probably where you found this presentation. Of course, your sales team system engineer, SE, can be contacted to help out. And finally, if all else fails, open a support case on the CSC. Now I will provide a demonstration using the Spirent TestCenter application depicted here to generate PGA IP traffic between two test ports. For that, we will create the device endpoints, sources and destinations for traffic, a bound stream block for the traffic parameters, and we will start and stop the traffic manually as opposed to using the command sequencer. And look at the results with TestCenter IQ. You may already have a Spirent TestCenter shortcut on your Windows desktop, but if not, you can open it from the Start, Program Files, Spirent TestCenter, and the correct version of the application as 5.13 is depicted here. For results with TestCenter IQ, you will no longer need to access the results reporter. You'll see that in the demo too. And most customers, unless they are using the Spirent TestCenter Lab server, don't need to access the Session Manager either. On to the demo now. Enjoy. As I start this demonstration, I'm going to remind you that if you're using a chassis, you can browse to it to download the application. So to begin with, I'm going to bypass the test wizards and set things up manually using either power mode or just dismissing the welcome screen and going to connect to chassis and reserve ports. Resize this window so we can see a little bit more about what I'm talking about. So I'm going to connect to that same chassis, which is an N11U chassis. And I'm going to reserve 2 ports. Now that the ports are reserved, you can see that they show up in the upper left of the test configuration. For this test, it's going to be just PGA traffic generation analysis, so I don't need any other protocols technologies selected. And I'll remind you too that once you've connected to a chassis, you can go to the Tools menu, and there you'll find firmware management, equipment information, where you can gather the serial number of your chassis, and this is where you can also perform your licensing management. First thing I'll do is check my ports, physical layer, and definitely make sure that their link status is up. If not, I'll troubleshoot why not. And to generate some traffic, or what Spirent TestCenter calls stream blocks, I'm going to select that. And what I'd like to do is add a bound stream block. But as you can see, since I haven't configured anything else, specifically devices that I can use as the endpoints for my traffic, it won't let me yet. However, if I go underneath an individual ports generator, that also gives me the ability to add what we call a raw stream block. So raw stream blocks don't use any endpoints like devices, and essentially you just set up the traffic parameters, including the frame that you can customize, even the entire frame if you like. I'll just go ahead and cancel that, because ideally if you're going to generate traffic between ports, you're going to use bound stream blocks with devices as endpoints. So I'm going to go ahead and select my all devices. So far nothing's configured, so I'll go ahead and add. Takes me to the Create Devices wizard, and I'll select both ports. And this is going to be a straight PGA traffic only test, so I'll leave traffic only device. And I do want IPv4 headers on top of Ethernet, but I don't need Ethernet VLANs in my configuration. But if I did, notice that I can go to configure VLANs for that. Importantly, you need to make sure that the MAC addresses are unique in your test environment. And of course, you have the appropriate IPv4 addresses for the subnets that you're plugged into. I have two ports back to back, and essentially they're going to be simulating the gateway for each other, and they're then of course going to be on the same subnet. So I'm not going to increment the IP address per port, just per device then. You'll see in a minute I need to make a slight modification to port 1's gateway to point to the device on port 2. As you can see on port 1, it's pointing to itself for the gateway. So we can fix that when I select Finish here. And now we're at the All Devices Emulated Device Interface tab. I'll go ahead and scroll over to where the IP information is and make that modification to Devices 1 gateway. Now that I have my devices, I can go back to my all stream blocks, and it should be satisfied to allow me to add a bound stream block using the traffic wizard now. And we can see we have both test ports. And now we're going to set up our endpoints. Our traffic distribution is going to be pairs, and I'm going to create bidirectional traffic between device 1 and device 2. Go ahead and add that. I can set up different frame sizes if I like. I'll just leave the default 128 bytes. I could adjust things in the IP header if I like, or even add a TCP or UDP header on top. And I can use port-based or load per stream block scheduling mode. I'll just stick with port-based, and I'll keep the default load at 10%. Since I'm not multicast testing, I'm not interested or concerned with adding any specific receive ports. Okay, now we have our stream blocks, one on each port. Notice on the first port we have device 1 sending to device 2. On the second port we have device 2 sending to device 1. And of course we're using our default settings for our generator, specifically fixed load at 10%. And we're just leaving our traffic analyzers at defaults. I'll go ahead and apply this configuration where it will push the changes down to the hardware, and they'll be set up and ready to generate traffic. The first time I apply, it also prompts me whether or not I want to use TestCenter IQ, which I do. So I'll go ahead and select that. And you'll notice it's going to launch in my default browser. In this case, it's Chrome. And it opens up the results library, which has a record of all the tests that I ran before, as well as the test in progress. Let's go ahead and select this test in progress. Since no protocols were enabled, it recognized it as a basic traffic test, so it just loaded the basic results profile, which has health indicators, summarized traffic results, and port frame rate chart. I'm going to go ahead and add a detailed stream results view into the profile. Just kind of adjust the size of these so I can see a little bit more at one time in my view here. And at this point, we're not running any traffic, so really the counters and everything is pretty steady. Let's go back to the application and start our, first we're going to start and enable ARP so we can resolve the MAC addresses between the two devices. In this case, they're emulating each other's gateways. Looks like all attempted ARPs resolved successfully. Now I can go ahead and start my traffic. And even though we selected to use Spirent TestCenter IQ, the classic results are still enabled. But I'm going to go ahead and switch over to TestCenter IQ, where now we can see at our summarized as well as individual port level statistics and our detailed stream results, which also is identifying the IP addresses and MAC addresses detected for the streams, and our traffic stream counts and rates, as well as whether or not any frame loss, drop frames is detected, and our latency statistics as well. And we can also see our port frame rate chart being updated based on our generator and receiver signature frame rates. That would be the actual Spirent TestCenter frames from our stream blocks. I can then save what we call a snapshot of the results. So whatever these counters are at the time that I'm saving this, that will be written into the database. I'm going to go ahead and save one more snapshot just so you can see. And now that I have snapshot save, I can toggle between live and my individual snapshot results. As well as now I can generate a report of those snapshots. I'm just going to go ahead and apply the traffic test report template, but you can certainly customize a report if you like. Even from the templates, you can do some customizations, which I'm not going to do too much of that here. You can just scroll through and see, what's available, what will show up in the report, how the report alignment details are. You can enable, I didn't put any DUT information in. In fact, I'll just go ahead and go back to the TestCenter application real quick, and you can see that in the test configuration, you have your TestCenter IQ settings, which enables you to manage your data, how much data is being collected, how large the database will eventually grow to, as well as you can add DUT information that back in the Spirent TestCenter IQ test report generation, you can see that that DUT information could also be added to the report as well. I'm going to go ahead and just preview the report rather than generating it. And then you can see a nicely formatted PDF will be generated based on the statistics that we've enabled. I can then download the PDF report now if I like. And that concludes this demonstration of setting up Spirent TestCenter to generate bidirectional traffic between two ports. Thank you for taking the time to view this presentation.